The universe is full of extremes. Black holes that warp the very fabric of space and time, vast stretches of empty void, and then, at the heart of our solar system, our own star, the Sun. It's a cosmic powerhouse, a blazing sphere of plasma that has fascinated humanity for millennia. For centuries, we've studied the Sun from afar, peering through telescopes and capturing its light on photographic plates. Ancient astronomers tracked sunspots and eclipses, while modern scientists built observatories to unlock its mysteries. But now, for the first time, we're reaching out to touch it, venturing closer than ever before. Enter NASA's Parker Solar Probe, launched in 2018, humanity's first emissary to a star. This daring spacecraft is named after Dr. Eugene Parker, the visionary who first theorized the existence of the solar wind. Its mission is nothing short of audacious: to fly directly through the Sun's outer atmosphere, the corona, and survive the journey. No spacecraft has ever dared to venture so close. Imagine building a car to drive into a blast furnace. That's the engineering challenge faced by the Parker Solar Probe team. The Sun's corona is unimaginably hot, and the probe must endure conditions that would destroy ordinary spacecraft in seconds. The probe's carbon composite heat shield, just 4.5 inches thick, is a marvel of modern engineering. It withstands temperatures up to 2,500 degrees Fahrenheit, protecting the delicate instruments inside from the Sun's relentless fury. Behind this shield, Parker's instruments stay cool, allowing it to gather data from a region we've only dreamed of exploring. These sensors measure magnetic fields, charged particles, and waves of energy, capturing the Sun's secrets in real time. It's a true cosmic daredevil, swooping closer to the Sun than any object in history. With each orbit, Parker edges nearer, braving radiation and heat that no other spacecraft has ever faced. Why take such risks? To answer profound questions that have puzzled scientists for decades. How does the Sun heat its corona to millions of degrees, far hotter than its surface? How does it generate the solar wind, a stream of charged particles that shapes our solar system and even affects life on Earth? Understanding these mysteries could help us predict solar storms and protect our technology. Each orbit brings Parker closer, traveling at speeds over 430,000 miles per hour, the fastest human-made object ever. At this velocity, it could circle Earth in less than 4 minutes. But this mission isn't just about our Sun, it's about understanding all stars. By studying our closest star up close, we unlock clues about the life cycles and behaviors of countless others scattered across the galaxy. Parker's journey is a testament to human curiosity and ingenuity. It's the result of decades of dreaming, planning, and relentless problem-solving by scientists and engineers around the world. It's a leap into the unknown, gathering data that will change our understanding of the cosmos. Every byte of information sent back to Earth is a step closer to unraveling the mysteries of our universe. The probe's discoveries will help us grasp our place in the universe, revealing how our star shapes the environment of our solar system and influences the conditions for life. We're not just visiting our star, we're unlocking the secrets of countless others, paving the way for future missions to explore the stars beyond. The Parker Solar Probe is proof that our desire to explore knows no bounds. It's a shining example of what humanity can achieve when we dare to reach for the stars. The Parker Solar Probe sends back a torrent of data, streaming information across millions of miles, bridging the vast emptiness between the Sun and Earth. But making sense of this overwhelming flood of information is a monumental challenge for scientists who must sift through mountains of numbers, images, and signals. The Sun's corona is a storm of plasma and magnetic fields, chaotic, complex, and noisy, with patterns that are often hidden beneath layers of turbulence and interference. Enter artificial intelligence, Parker's indispensable co-pilot, a digital partner that never tires and can process data at unimaginable speeds. AI sifts through petabytes of data, spotting patterns invisible to the human eye, detecting subtle changes and correlations that would take humans years to find. It analyzes images from the probe's Whisper instrument, tracking faint structures in the solar wind, and mapping the ever-shifting boundaries of the Sun's influence. This partnership between human and machine decodes the Sun's secrets faster than ever before, combining intuition and experience with raw computational power. AI cleans up noisy images, revealing the true structure of the corona, and allowing scientists to see details that were once lost in the glare and chaos. It transforms raw data into stunning visualizations, making the invisible visible and turning abstract numbers into breathtaking images of our star. Without AI, many discoveries would remain buried for years, hidden in the endless archives of unprocessed data, waiting for someone to find them. The sheer volume of information demands this new approach, as traditional methods simply can't keep up with the pace and scale of modern space exploration. AI accelerates discovery, turning Parker's mission into a dynamic exploration, where new insights emerge in real time and every moment brings us closer to understanding the sun. Machines now extend our senses into the most extreme environments in the universe, allowing us to explore places we could never reach on our own. The Parker Solar Probe and its AI systems mark a new era in space science, where human curiosity and machine intelligence work hand in hand to reveal the mysteries of the cosmos. The sun's corona is millions of degrees, hotter than its surface. Why? For decades, this coronal heating problem baffled scientists. Parker's Solar Probe, with AI's help, finally brought answers. The probe flew through the corona, collecting data on magnetic waves called Alfvén waves. These waves, generated by the sun's tangled magnetic fields, travel upward and break, releasing energy as heat. It's like cracking a whip. The energy snaps at the end, heating the plasma. Parker's data showed these wave-breaking events in action. AI filtered the data, revealing the process in unprecedented detail. This discovery provides strong evidence for a once controversial theory. We're no longer guessing. We're watching the sun heat its own atmosphere. A huge piece of the puzzle has snapped into place. The mystery isn't fully solved, but we're closer than ever. As Parker ventured deeper, it found the solar wind full of wild magnetic kinks, switchbacks. These S-shaped twists whip the magnetic field back toward the sun, then flip again. Once rare, Parker found them everywhere near the sun, a shock to scientists. Switchbacks are linked to sudden bursts of speed in the solar wind. AI detected thousands of these events, building a statistical picture of their size and energy. The leading theory, magnetic reconnection near the sun's surface, creates these kinks. This process releases energy, sending switchbacks out with the solar wind. Understanding switchbacks is key to unraveling how the solar wind is accelerated. Parker's discovery has fundamentally changed our model of the sun's outflow. The solar system isn't empty. It's filled with a vast, intricate cloud of cosmic dust, stretching from the outer planets all the way toward the sun. These tiny particles, remnants of ancient collisions and the building blocks of planets, drift silently through space, shaping the environment around our star. For decades, scientists predicted that there should be a dust-free zone close to the sun, a region where intense solar heat would vaporize any dust that ventured too near. Yet, until recently, no one had actually observed this mysterious region. The Parker Solar Probe, equipped with highly sensitive cameras and advanced AI-powered imaging systems, began its daring journey, spiraling ever closer to the sun. Its instruments were designed to track and analyze the faintest traces of dust, even as the probe braved the sun's extreme environment. As Parker approached the sun, its data revealed a dramatic drop in dust density. The probe confirmed for the first time the existence of the long-theorized dust-free zone, where the sun's heat becomes too intense for dust to survive. Parker precisely measured the boundary where dust begins to vaporize, providing a crucial clue for understanding how the solar system has evolved over billions of years. This discovery sheds new light on how planetary systems form and change over time, revealing the delicate balance between dust, heat, and gravity in shaping worlds. Dust is the raw material for planets. Knowing exactly where it can survive tells us about the early conditions that led to the birth of planets like Earth, and even the origins of life itself. These findings also inform our study of distant stars with their own dusty disks, helping astronomers compare our solar system's history to those of other planetary systems across the galaxy. By exploring the sun's dust environment, Parker is helping us uncover the universal rules that govern planet formation everywhere in the cosmos. Parker's groundbreaking journey is rewriting our understanding of the solar neighborhood, revealing secrets that connect our own origins to the wider universe. To reach the sun, Parker needed help from Venus, using its gravity to slingshot closer. During a 2020 flyby, Parker's Whisper camera captured a surprise, a faint glow from Venus's night side. Venus's thick clouds were thought to hide its surface, but Parker saw features like Aphrodite Terra, The camera detected thermal emission, heat radiating from Venus's scorching surface. For the first time, we glimpsed the planet's surface through its clouds. This accidental discovery opened a new way to study Venus's geology from orbit. Future missions can now map Venus's surface and search for volcanic activity. Parker, built to study the sun, became a revolutionary Venus explorer by chance. Sometimes science finds what it never set out to discover. Parker's serendipitous observation changed how we see our sister planet. Solar science isn't abstract, it affects our daily lives. We live inside the sun's atmosphere, constantly bathed in the solar wind. Powerful solar storms like coronal mass ejections can disrupt power grids and satellites. Parker's research helps us predict these space weather events, protecting our technology. Understanding the corona and solar wind is crucial for forecasting solar storms. Discoveries like switchbacks reveal how these eruptions begin. Better forecasts mean more time to safeguard infrastructure and astronauts. As we plan missions to the Moon and Mars, Parker's data helps us protect explorers from radiation. By mapping the sun's hazards, we pave the way for humanity's future in space. The quest to understand our star is inseparable from securing our future. Parker's mission is far from over. The most exciting discoveries are still ahead. Each orbit brings it closer to the sun, flying deep within the corona. Soon Parker will sample the solar wind at its very source, crossing boundaries never explored. This data will reveal how the solar wind is born and accelerated. Parker will also map the sun's magnetic field, tracking the solar cycle up close. Long-term monitoring will refine our models of the sun's internal dynamo. Each pass adds new layers to our understanding. The probe will push the limits of engineering and exploration until at least 2025. The discoveries yet to come may once again reshape our view of the sun. The Parker Solar Probe story is about connection, to our star and to the cosmos. The sun powers life, shapes our world, and creates the auroras we marvel at. Parker embodies human curiosity, turning ancient questions into scientific discovery. We no longer wonder from afar, we send machines to find answers. Parker's findings resonate beyond solar physics, revealing the universal language of stars. By studying our sun, we learn about distant worlds and the potential for life elsewhere. Every secret Parker uncovers shines light on the universe's possibilities. Next time you feel the sun's warmth, remember our robotic explorer braving the inferno. Parker is not just exploring the sun, it's exploring our origins and our future. In its reflection, we see a clearer picture of ourselves and our place in the cosmos.